The James Webb Space Telescope is one of the most complex and sophisticated scientific instruments ever built. A joint mission between NASA, ESA and the Canadian Space Agency, it's seen here folded and packed for launch in a clean room at Europe's Spaceport in Kourou, French Guiana. Operating 1.5 million kilometres from Earth, the observatory will unfurl in space to reveal a 6.5 metre wide primary mirror made up of 18 individual hexagonal segments, a smaller secondary mirror and a giant multi-layered silver sunshield. The engineering is an impressive example of human ingenuity, but when it comes to science, Webb promises to reveal the basis of our very existence.
The origin of Webb is the search for our origins. We want to find out where the first galaxies formed, how they formed when they started making their stars in the very early universe not long after the Big Bang. And to do this, Webb uses its big mirror and its infrared vision to look into these really early days, observe the light from these galaxies that's been traveling to us for billions of years, and it shows us these galaxies how they were billions of years ago.
In orbit now for more than 31 years, the Hubble Space Telescope has already transformed our view of the cosmos. It's revealed the accelerating expansion of the universe, the birth and death of stars, the evolution of galaxies and storms on Saturn and Jupiter. But Hubble primarily detects visible light, the wavelengths we see with our own eyes. By viewing in the infrared, Webb will be able to give us a new perspective on the universe. To capture photons of light that have travelled across space for billions of years, the new telescope is loaded with innovative detector, optical and cooling technologies.
The telescope itself has to operate at a temperature of minus 233 degrees Celsius. And that means that all of the systems on board have to be able to cool into space behind the giant sunshield. And getting that sunshield, the size of a tennis court, to unfold into space and shield the telescope has been one of the biggest engineering challenges solved along the way.
Webb's 4 scientific instruments include MIRI, a mid-infrared camera and spectrograph. This involves a consortium of European institutions led from Scotland. And NIRSpec, a near-infrared spectrograph, which is led by ESA.
It's very important because it will allow us to analyze the light of the astronomical objects we will observe. These instruments will split the near-infrared lights from the astronomical object into its components. And this is very useful to scientists because from that they can understand the physics of the objects they are observing, what are the temperature, the elements, the physical condition, and therefore we can understand what's going on the objects we observe.
So, the James Webb Space Telescope will not only be able to view newly formed galaxies and stars, but determine what they're made of, and in the case of planets, even whether they have atmospheres capable of supporting life. It's taken more than 30 years of planning, designing and construction to get to this point, but it's going to be worth the effort. Like Hubble before it, Webb has the potential to transform our view and understanding of the universe.